So this is going to be on short circuits, which is when we terminate or look at our two condition booleans and terminate it if they are true. So let's kind of look at those tables. Consider the AND operator. We have to have both of these to be true for the AND operator to evaluate as true. So if any of them are false, or if the first one is false, we know that we don't even need to look at the second. So here we have x is false, so this will be false. We could skip reading these inputs because both of them have to be true. Here, it's false, so it's false, but it's not first, so it does have to go through them both. The OR is the opposite. If one of them is true, then the OR is true. So these two are true first. This will be true. We don't look at these. Here, false is first, true is second, so it's true, but we have to look at them both. If the result of the Boolean expression can be determined with the first, the second's not evaluated. Example. I think this is to stop the division by zero error, right? Yeah. If we have 0 people sharing pizza and we divide by 0 people, we get an error. Dividing by 0 will crash. We can't divide by 0. We can't even do that on our calculators, right? We get an error there. So we should be familiar with this type of error. So now we'll say if the number of people isn't 0, we just skip to the next. We skip evaluating the division by 0 and print out. We have something else. We could evaluate true here before it would print out not enough pizza. Let's look at the editor. How many people are eating? We want to test 0. There's not enough pizza for everyone. What? That's weird. Well, it kind of makes sense. I guess you need an infinite amount of people to feed no people. I don't know. Doesn't matter. But the key is we're not crashing because there's not a division by 0 error. Let's check out this. We have the user input 2 numbers to input if they're divisible. Instead of using like a modulo, which is another way to do this, we cast it. If you do have a remainder, it will be truncated. It would be a decimal point if you have a double divided by it. Because remember, doubles can have decimals and ints can't. So that's one way to check it. We could also change it, but let's see what our assignment is. I think right now we get an error if the user inputs 0, so we have to fix that just like was done in that previous thing there. Yeah. Enter dividend 32. Oh no, an error because we're not short circuiting it. So if divisor does not equal 0, zero is not, well, maybe I'll put in 32 again. And that's it. We just wanted to change the code so we had a thing to short circuit if the divisor was 0. The bug, your job is to short circuit.